Hello everyone, my name is Manpreet and today I'm going to explain the various performance metrics and evaluation metrics used in image classification and segmentation. As we know, we have the various metrics available to evaluate the machine learning models, but some metrics are application specific, like sometimes we use a particular metric to evaluate our model, but its performance may get affected depending upon the metrics that used to evaluate the model. Which metric can be used for which kind of model, that we will explain in this video. So, in this video, I'm going to explain first of all the confusion matrix, and then true positive rate, that is the type 1 error, and false negative rate, that is type 2 error, and we will understand the accuracy and the precision, which is also known as a positive prediction value, and we have a concept like recall, which is also known as a sensitivity, and we have beta score, specificity, ROC, and AUC curve. Some of these metrics will be explained by me, and the remaining metrics will be explained by my friend Vaneet. So let's get started. In order to understand the other metrics, so we need to understand what is the confusion matrix. Confusion matrix is not a metric, but it is a matrix, that is 2 cross 2 matrix, in which the top values represent the actual values, that is the columns. 1 means true and 0 means false, and similarly the rows represent the values predicted by the model, like the values in the matrix represented by the green color, these are the correctly predicted by the model, and each field in the 2 cross 2 matrix is useful and have its own meaning. Like if the actual value is 1 and the model predict 1, then it is a true positive case, and if the actual value is 0 or false but the model predict it as a true, then it is false positive, and if the actual value is 1 and the model predict it as a 0 or false, then it will be considered as a false negative case. And similarly, if the actual value is true and model predict it as a correct, that is 0, then it will be the true negative case. So false positive is also known as a type 1 error, and false negative is known as a type 2 error. The values or the fields in the diagonal, these are the most accurate values that are predicted by the model, that is the true positive and true negative. And our main aim here for the binary classification is to reduce the type 1 error and type 2 error, whereas to maximize the values of true positive and true negative to get the best performance of the model. So here let's have a look at the data set for the binary classification. If we have a binary classification and suppose, let's say we have 1000 images and we have two classes. One class is of the images that contains the images of car, and another is a non-car images. in the left hand side, the data set that is which is balanced, if the if the if the both the classes having the 500 images, like 500 images of car and 500 images of non car, then it will be considered as a balanced data set, because both the classes have the equal number of images. And but the if the non car images are 600 and the car images 400, then still it can be considered as a balanced data set. And if we have non car images 700 and car images 300, still it can be considered as a balanced data set, because this is the 70-30 ratio. But if we decrease the car images to 200 from 300, and the non car images increase the non car images to 800, then it will be considered as an unbalanced data set. Because if our model will be trained by using the unbalanced data set, then it may get biased based on the based on the based on the output that belongs to the class which have the more number of training examples. Like the non car having the 800 images and car images are 200, then uh, any model may get biased based on the non car images, and it may affect the accuracy of the system. So for the here the point is, for the balanced data set we can use the different metrics to measure the performance of the model. And if the data is unbalanced, then we have different metrics to measure the performance of the system. So next is type 1 and type 2 error. So here, for the binary classification method, false positive is known as a type 1 error, and false negative is also known as a type 2 error. Type 1 error can be computed by false positive rate, which can be defined as the ratio of false positive and summation of false positive and true negative. Similarly, the type 2 error can be given by the false negative rate, which can be defined as a false ratio of false negative to the and summation of true positive and false negative. So here the accuracy, the concept of accuracy. If we define the accuracy for the in the layman language, then it can be defined as the total number of values predicted correctly divided by the total number of values. As shown in the figure, the values that are predicted correctly are represented by the green color, that is the true positive and true negative. So accuracy will be the summation of true positive and true negative divided by the total number of values. So accuracy can be used for the balanced data set. If the data set is balanced, then accuracy metric can be used to measure the performance of the system. But what if the data set is unbalanced? Then it may result based on the that then our system may get biased based on the more number of training examples that belongs to the particular class. So next is the example. Let's say we have the unbalanced data set in which the total images are 1000 and there are 800 non-dog images and 200 dog images. Out of the 800 images, we can see that the 740 are predicted correctly and 60 are misclassified. And out of 200 dog images, our model predict 100 images correctly and 100 images incorrectly. So then accuracy will be the if we put these values in the accuracy formula, then we get the 0.84 accuracy, and which can be converted into the percentage by multiplying it by 100, that is 84%. So here the number of non-dog images are 800, so the accuracy is 84%, and our system get biased based on the non-dog images, because the system has seen many images of the non-dog, and so it predict these images more correctly. More number of images are predicted correctly by the system, which are non-dog images. So its accuracy is 84%. Next is the precision. Precision can be defined as the true positive, ratio of true positive and summation of true positive and false negative. So which is also known as a positive prediction value. Here the intuition is to reduce the type 1 error, and if the type 1 error is less, then the precision value will be high. And we can use the precision for the unbalanced data set, and the applications such as the email spam detection, these use the precision to evaluate the model performance of the model. And the precision can be used where the greater impact of the false positive, as I explained, the to reduce the type 1 error we can use the precision. Fine. Okay, then next is, here is an example that which I explained previously with the accuracy. And here we have the unbalanced data set, same example as previous. We have unbalanced data set, we have total images 1000, non-dog images are 800 and dog images are 200. If we put these values into the precision formula, then we get a value of precision with respect to class dog as 0.625, and we can, when we multiply it by 100, then we get 62.5%. So this is used, precision is used in those applications where we want to reduce the false positives or the type 1 error. Okay, next is the recall. Recall is the ratio of true positive and summation of true positive and false negative. So here intuition is to reduce the type 2 error. If we reduce the type 2 error, then the value of the recall will be the higher, and the recall is also known as a true positive rate, and sometimes it is also referred as a sensitivity. As I explained earlier, that accuracy can be used for the balanced dataset only, but for the unbalanced dataset we can use the recall, and it is used in those applications where the false negative the false negative have the greater impact on the results, and those applications where we need to reduce the type 2 error, applications such as a cancer prediction. Let's say let's say the actually person having the cancer, but the model predicted as a non-cancer. So it may cause a great disaster for the persons, and it may prove to be very dangerous for the person who is having the cancer, but it is predicted as a non-cancer. So in such applications, we when we need to evaluate the model, we use the recall as a metric. So after that, other metrics will be explained by my friend Vaneet, and thank you so much.